Hello everyone, welcome to the Study Hacks Institute of GIS and Remote Sensing. Today I will try to discuss a very important topic, mainly how we can easily use the SAM model, segment anything model on our satellite imagery, and then we segment the different types of feature. So it's very useful for very quickly we can get the segmentation for any feature. I will show you all of things step by step. I hope you can easily do it for any satellite imagery after downloading, and then you can easily work with that segment some model. So there are the lot of uses for the segmentation. In this time, I will not go to the further. I just show you that what's the process, how we can easily apply to segmentation using SAM model. So let's go. I will show you explain one by one. So first of all, here you can see this is my satellite imagery. So in this time, I want to use this satellite imagery and then segment all of feature. Mainly here we can find out that water body, we can get the some building, footprint, okay, building, okay, you can see. So in this time, if you want, you can use any satellite imagery. If you want, you can use here the drone satellite imagery, or if you want, you can also use here the different types of aerial satellite imagery. Anything you can use for the segmentation using SAM model. So in this time, I choose this imagery, and now I want to use this imagery, and then I use here the SAM model to segmentation for the different types of feature or object. So here you can see this is my satellite imagery. I already uploaded and cut my study area. So first of all, you just try to find out your satellite imagery. This it can be drone image or it can be aerial photography or any image which you want to use. And it also better result when you want to use the high resolution satellite imagery. Okay, if you want, you can use the Maxar satellite imagery or Spot satellite imagery or NAV satellite imagery. So this type of high resolution satellite imagery you can easily use. As well also you can also use the drone imagery or aerial photography. So we can easily make the segmentation of different types of object from the images. So let's go how I can easily work with that. If you want, you can also use here the Google Colab, or if you want, you can also use here the Jupyter Notebook. So in this time, I choose the Google Colab, and here you can see this is the main website about the segment anything model. So here you can see basically it's a one kind of new artificial intelligence model for Meta AI that can cut out any object in any image with a single click. Okay, so there are the lot of uses at present time for the image segmentation in the geospatial sector. So in this time, I will show you that example how we can easily use the segment anything model, and further how we can easily work with the different types of geospatial software. So let's go. So in this time, simply search here Google Colab, and further you can get that welcome to Colab. Just simply click on here, and further I just try to open a new notebook. Just simply click on here, and we can get this type of interface about our new Google Colab code editor. I simply put here the new name. Suppose I put this SAM, or you can put any name. So now for the runtime, it's very important when you want to work with the big model. So just I simply change the runtime. I just use that GPU and save it. After that, simply click on the connect. Okay, so now it's connecting. Okay, now further I just try to install. Suppose I want to install it the some package. First package I need to install for that segment geospatial. So just put here the segment geospatial, and I also need to the leap map for visualize this data. So just put here the leap map. Okay, I simply click the run. So now these two packages is simply installed in my system. You can see it will work. So it takes some time for downloading all of segment geospatial package as well as leap map. Okay, satisfied. So here you can see all of leap map package and also segment geospatial package is successfully installed in my system. And now I simply import. I import the OS as well as I also need to import the leap map package and also import the segment mainly SAM geo. And I want to just use here the from SAM geo and then import the segmentation model. Just put here the SAM geo and also import some other library such as show image as well as also imported that download file. So just I can easily download the different types of file after working. So just put here the download file and also use here the overlay. So that's why I can easily use the overlay images as well as if you want you can also, so just this type of package I can simply import it in my system. It's also done. So now after doing these things in this time, I need to load. I need to load the import my image. Okay, so I simply click on here, and here you can see this is my imagery, satellite imagery. This imagery I want to upload in my Google Colab or my Google Drive. So further I can easily use this image and then work with that. So very easy. It's simply you can simply click on here. You can see the upload option and then simply go to your local storage where you stored your imagery. So just I try to find out from my download folder. Here you can see the imagery look like that. Here you can see, yeah, so this is my satellite imagery. I simply click on here and also okay. So now we can see it will be working to uploading this satellite imagery. So further I can use this imagery and then try to make the segmentation. Okay, it can see it for this here, this satellite tip. So after doing these things, I want to visualize this imagery. So for that, I just take a variable. Suppose I put the variable name is that image, and then I just call this image path. So just simply copy the image path and then paste here. Okay. So now this variable image is stored my imagery, which I uploaded in my Google Drive. You can upload any kinds of satellite imagery. You can for the segmentation. Okay. After doing these things, I just simply take a new cell. And now I want to visualize this imagery. Okay. So for adding the visualize this imagery, I just simply use here, I just simply put a leap map function for visualize this imagery. So for that, I just simply put here the m. I take a variable m and then call the leap map this library dot I call the map function. Okay. So I simply call the leap map library. From here I call the map function. And further, I just try to put here the center. Okay. So I can simply put here the center. Suppose I just put here the center equal. I just make a list. I simply put here that longitude and latitude about that. I simply put here the 23.8041. Then comma. I just put here the longitude 90.4152. So this is my latitude and longitude for my study area. I simply put the center. And further, if you want, you can also define your zoom level. Suppose I want to put here the zoom level equal to 18. So now it will be a zoom on your package 18. As well as if you want, you can also mention about the height of the leap map. So just I put the one argument is the height equal to, I just put here the height. Suppose I put here the suppose 100 pixel height for my tiles. So now you can see in this time, what can I do? Just I simply take a object m and call the leap map library. Okay. From here I call the map function and center. Just I put here my latitude and longitude for my study area. And further I put here the zoom level. And then I also define the height. So you can simply define all of these things one by one. And further, after doing these things, I just simply call the another pack library. I want to visualize these things. Suppose I just simply put the m because this is stored up my full map. So now in this time, you can see what happened. I just simply click the run. So now it loaded a map. Okay, so basically it's one kind of OpenStreet map. It loaded in my here. I can easily visualize my study area. This study area I want to focus. So now it will work. You can see it takes some time. It's depend on your internet connection. Okay, so I need to reload this page again. I think some problem. So I run the code again. Okay, so just I reload my page again and try to check what happened. Okay, I hope not to right. So now just try to show the maps. Okay, great. So now we can get visualize this type of OpenStreetMap for my study area, which is show the this type of latitude and longitude, and also the zoom level 18 and height is the 800 pixel. So now I want to visualize this image, which image I want to show in here. So for in this time, you can see I already imported my image, and this image I want to store it in this image variable. So now this image I want to add on my map, so that's why I can easily visualize it, and further I can easily apply the SAM model. So let's go how I can visualize this imagery in here. For image visualization, first of all, I call my object. My object is the M because M is stored my this OpenStreetMap. Okay. So for that, I take a new cell just below this map, and further I just simply call map dot layers, and I just show only for the one layer. So just put in the -1 and put here the visibility. I want to put here the visible equal to true because I want to put here that visible equal. I put the false. Okay. And further, I want to add this raster. In this time, this is my image. This image is the raster format. And this image I want to visualize in my map. So for that, I simply put at the M. It's M is my object. M dot add raster. So just put here that add raster, and further call this image where I stored this image. You can see I stored this image in this variable. I simply copy this variable name, and further I just paste here. Okay. So now my object is added with my image, which image I already uploaded in my Google Drive. So now let's check about the image. So just I simply call my object and try to run the code again. So now if there is no problem, then it will show the imagery in here. And now let's check what happened. It loaded. Okay, great. So now here you can see we can get this type of imagery. This imagery I uploaded in my Google Drive. It properly visualized on my lip map package. I just try to add the layer. So now this image I want to use, and then further I want to make the segmentation. Okay. So here you can see I use the same imagery, which I already show you that my QGIS software. The same imagery I will just visualize in my Google Colab using the leap map function. So now I want to create the SAM model. Okay. For the SAM model, I just take a variable SAM equal, and I call this SAM GEO. And now I define here some keyword and key value. So one keyword is the model type. So in this time, I simply put here that model type equal. I put here that bit is. So it's one kind of model type of SAM or segmentation, anything model type. I put here, and then put here the SAM. And just put here that none. Okay. So just I put here the two argument. One is the model type, another is the SAM. Okay. I put here the none in here. And further, after doing these things, I just click to the run. So now you can see it will be loaded, this SAM model. And further I want to use this model and segment. So here you can see it loaded all of functionality about this model. This type bit ace will be loaded, and downloading all of things in here about this model. So further I just use this model SAM and use the segmentation. Here you can see it's successfully done all of those things. And now I want to just use this model. Okay. So just I simply call this variable name SAM. And then I want to show the max. So just put here the show max. And I want to put here the binary max. So just put here the CMAP. And put here the binary R. So just put here the binary R. And further click to run. So now you can see what happened. So it show this type of problem. Okay, I just put here the show max CMAP equal to binary R. So let's check the problem. Okay, so it show that SAM best no attribute. Okay, so before that we have to just make the SAM generate. Okay, so after showing showing the binary marks, we have to just add the new cell and try to add the generate this imagery. Okay, so further I simply call the SAM and put here that generate. I want to generate which one? I want to generate this image. So I simply call my image variable name image, and I also put the output name. So just I use here the output equal to, you can put any name. I put the max tip. Okay, and further I put the another argument. This is the foreground. I put here the foreground equal to true. So just put here that true, and then further unique. I also put the unique is the true. Okay, just put the boolean operator unique equal true. So in this time, I just simply call my model SAM, and further I generate. So I simply call my image. So basically this variable is stored my image, and I put the output name is the max.tip, and then all of those things will be boolean operated true. So now try to run the code again. So now it generate the max, mainly generate the segmentation for my imagery, which image I want to input in this time. And also put the output is the max.tip. Okay, it's done. So now I want to show the binary. Okay, suppose only for the black and white color, I want to show this result. So now let's check what happened. Okay, done. So in this time here, I can find out only for the binary segmentation. You can see we can get that white and black only for the binary segmentation. And when I refresh these things here, you can see it also added a new file marks.tip. Okay, so in this time, this binary segmentation file is stored in the marks.tip file. If you want, you can also store it that, then you can easily get the binary segmentation. Okay, so I want to add the more better visualization. So for that, what can I do? Just I take the new cell and I want to show the annotation. Basically, I want to show about that annotation. So that's why it show the different types of color. Okay, we can easily get this result from here. So for that, I just simply call my model SAM and show ends. Ends means annotation. And then I simply put here the define about the axis. I don't need any axis, so just I put here the axis equal to, I just put here the off. And further I put here that alpha equal to 1. For that, I put the output. Suppose I show the output file name. I put the output equal to, you can put any name. I put the name, suppose annotations dot tip. Okay, just I put this. So now just click the run and check what happened. Okay, great. So now here you can see the result, this type of result you can get. So now for the segmentation, you can get all of the feature or object will be get the segment. Okay, you can get this type of segmentation feature, all of things here you can see. Okay, so in this time, if you want to run this, you can simply click on the refresh. You can see one file also added in here, annotation.tip. Okay, so now further you can easily use, and then you can show the different types of object has the different types of color. We can get these type of things. So we can get all of building footprint here. You can see also get the water body, this type of color. We can get the breeze, all of featured on the satellite imagery. We can easily extract from here. So now it show about the annotation about that. And further, I also add the more interesting visualization. So that's why you can easily compare these two layers at the same time. So I want to make the one panel, it show about the satellite imagery. Another panel show about that only for that annotation image. So then it look more beautiful. So for doing these things, I simply help of leap map. So just I call the leap map dot, I just simply call the function. It's called that image comparison. So just I simply call the leap map and put the function image comparison. Yes, just I simply call the leap map and call the function image comparison, and I want to put the image name. So one image is the satellite tip. Okay, so just I simply put here this satellite tip. So just I simply put here that imagery name satellite tip, and another is show about that annotation tip. So just I put here that quotation close. Okay, so just I want to show that comparison between two map. One is the satellite tip, another is the annotation tip, which I already create. And if you want, you can also put the level. Suppose I put the level 1. I put the level 1 equal to, suppose level 1 is show about the satellite and level 2 about the annotation or segmentation. So I simply name it. Suppose I put the level 2, basically it show about the image segmentation. I put here the image segmentation, and level 1 it show about the satellite imagery. Then it also add the label. We can easily get the idea from here. Okay, we put the label. So now in this time here you can see, just I simply put the leap map, and it's a package. From the leap map I call the image comparison, this function, and I simply put here the satellite tip, this is my one image, and also call the annotation tip, this is my another image. I put the label for that. So now just click the run. In this time what happened you can check. Okay, we can get this type of problem. So that got an unexpected label 1. Okay, just I simply check it. Okay, just we have to put here the label LA. So now try to check that again. Okay, so now we try to creating We just run the code again. I think some networking issue. Or if you want, you can simply copy the path about that. Suppose I simply copy the path and then paste here this path of satellite tip, and also just simply copy the path of annotation tip. Paste here. Okay, so now try the other one again. Okay, put at the wrong spelling. Okay, so it's the label 1 and also put at the label 2. Okay, so you careful when you write the code, you try to put the correct spelling. Better. Okay, so now great. Here you can see. Now we can get the perfect result about that. Okay. So in this time we can easily compare the two images. One is the segmentation, another is the satellite imagery. You can see this is our image segmentation. Also you can see this is our satellite imagery. Okay, so now we can easily compare this type of feature which I can get from here. After the segmentation, we can easily get the idea about that is a feature or is object. Okay, so here you can see it look like that. We can easily compare comparison the two imagery. One is that satellite and another is that this imagery. You can easily do it. As well as if you want, you can also increase the alpha value and check the layer about that. Suppose you just take a new cell and I want to increase the alpha value or decreasing the alpha value and check this imagery. So further I simply call my object. Basically it's stored in my leaf map object. I put here the add raster and I want to add the raster from the annotation. So just I simply copy this file, copy this path of this file, and then paste here. Just paste here. Okay. So now I want to visualize it, as well as I also increase the alpha value. Suppose I put here that alpha. So just I put the keyword is the alpha equal 0.5. Okay. And if you want, you can also put there the layer name. Suppose I put the layer name. Well, I put here the layer name is the max. Okay. So now try to add these things. Simply click the run and then check what happened. Okay. So now we can get that. You can see it will work. It loaded. Okay. So now we can get this type of final segmentation result look like that. And after doing these things, if you want, you can also just export these things as a shape file, or if you want, you can also export these things as a any kind of polygon. You can easily do it, and further you can easily work with for that other types of geospatial software. After downloading the tip, after you can simply convert into these things from, suppose it show the tip image, you can simply this type of feature you can convert as a shape file or boundary or geo package. Okay, so further you can easily use it. Suppose here you can see I already downloaded the shape file, all of things of all of max file. So you can see we can get just I simply down it. So you can easily download this type of feature. So then you can easily get it. So now further from here you can easily calculate the area, as well as you can also different types of analysis after downloading the shape file. Okay, this type of segmentation object, you can simply download the shape file, and further from here you can easily calculate the area as well as different types of work we can easily do. Okay, after segmenting object. So today I will show you that how we can easily work with the segment model, mainly SAM model, segmentation anything model. And further, I also try to describe a more interesting topic for the deep learning or machine learning. This type of things how you can easily work, and then we can easily work the different types of satellite imagery or drone imagery or aerial photography. Okay. So today is no more. Thank you for asking that. Stay happy, stay safe. Thank you.